our channel Chem Achievers. Today I will discuss about some problem about CSIR NET related questions. So in this video I have showed different reagent chemistry application. In our previous video I already discussed 4 questions about for different perspective. In this video I have discussed 4 questions which are totally different or reagent application which came to your CSIR exam. Let's start. So see here I am using one reaction. You see it came December 2011 net exam. See here, this is the scheme, reaction scheme and reagent are used. So here you see that here this aromatic ring they use lithium liquid ammonia and tertiary butanol and they use MCPBA. You know MCPBA, and this condition you have to get A and B, and there are the 4 options. This is one A, B, C, D. So there is the 4 options. You have to identify which one is the main answer. So you use short techniques because in your net exam you have a less number of time for solving one questions. So first you see how can I approach first. So here you use that lithium liquid ammonia tertiary butanol is condition of Barks reduction. So in Barks reduction, what happened? Here you see in this ring one methoxy group is there. Methoxy group is electron donating group. So I already told in our name reaction Barks reduction. So that this methoxy group is electron donating. So in Barks condition, the reduction in Barks condition, what it will come? In Barks reduction, one, the rearrangement of the double bond come to near to methoxy bond. Near to methoxy bond, and here one methyl group also there. So in this 4 option, the double bond near to methoxy bond is here one, here one, here one. It is not there. So methoxy group it is not there means this option is wrong, because always electron releasing group and the formation of double bond from aromatic ring come to adjacent to methoxy group. So this double bond is there, and here this double bond is near to methoxy group, and here this double bond is near to methoxy group. So first option criteria you have to select one. So next option, so you have to see in these 3 option in first step A. So here is methoxy group is near. Here you see another methyl group is there. Methyl group also plus I effect is there. Plus I effect means donation of electron. So it is also electron releasing group. So another double bond will shift to the near to methyl group. So see here in this option is wrong. So here in this option, this double bond is far from this methyl group, but near from methoxy. So this is cross. So here it near to double bond methoxy methyl group, and here also near to methyl group. So in this option, these 2 are maybe possible, because first A you will get, then you will get to B. So now what happened? Here in this option you have to select what will be the product. So you get you reduce 2 option. Now you have a 2 option is there. So in this case you have to see these 2. Now next step you will come. You have to get this first A option is this one. For your concept. And then methoxy MCPB use. MCPBA form is epoxidation it will form. You know already MCPBA form epoxidation. So which will be form main epoxide? This one or this one? Because you have to select these 2. So where epoxide will form? In these 2 options. In this case they are showing this is there. In this case they are showing this is there. So you have to know the basic concept. Wherever this double bond is electron rich double bond. So and the MCPBA supplied electron deficient oxygen, because MCPBA whenever MCPBA supply their electron deficient oxygen to the double bond, that double bond should be more electron rich. So in these 2 options you have to select that here methyl group plus I effect, and here methoxy group plus R. So plus R effect is more than plus I effect. So in this case this methoxy group is there. So here this option is correct, because the electron deficient oxygen will bond to this double bond, not adjacent methyl double bond. So this option is correct. So this way you have to approach it quick way. First you select this condition, what happened, next you select this, what is the condition. So in this way you have to approach. Now in this question you have a little bit idea of the approach of different questions. Now I will go to the another example. Now I will discuss another example of this application of reagent chemistry. Actually this is the name reaction. This name reaction directly they can put. So this name reaction you have to know. I know you already in your M.Sc or B.Sc. So now here I explain this name reactions. Simple. You have to say this question came June 2012. So here see, they use this azide amine and heating B and then B. And A intermediate you have to expand what will be the intermediate, and then you have to suggest what will be the product B. So there is the 4 options. Okay. So in this 4 options you have to see A is a SL cation, intermediate, this one ring. B is SL cation, this one is the structure. C is the SL nitrine, so this one is the structure. And D is the SL nitrine and this one is the structure. So first option, here you see azide, they use heating, and here amine. So this reaction is this name reaction is actually rearrangement will happen. Rearrangement. So here one rearrangement will happen. That rearrangement give nitrate, because azide structure you know, azide double bond N double bond N plus N minus. So this is azide. You know this name reaction directly you can see any azide is there. So you have to get this nitrine intermediate. So here you see what will be the nitrate in this option. This is 2. So in this is cross, this is cross. So this nitrine intermediate will come. Nitrine intermediate go to rearrangement. This is rearrangement and that will come there. So here that will come there means you have to see what will be the middle product. Middle after rearrangement the product will like that. I will write it like that. N bond, C bond. Then here is amine is there. Okay. So that amine will attack there. So this is the product. Okay. So you understood? This is rearrangement happen. If you got the nitrine in this one, and that will be the product. So not this one, not a 4 member, because 5 member is more stable. So you have to know how can approach the question. First you know the first step, then go to second step. Now I'll go to the another. If you use this PCC, so PCC here 2 alcohol are there. So that 2 alcohol, not 2 here one see this is benzyl alcohol. This is attached to benzene ring, and this is 1 alcohol is like that. So this benzyl alcohol is not oxidized. Only this alcohol is oxidized. So this alcohol is oxidized to ketone. Okay, this double bond is there, it is okay, but this alcohol is oxidized to ketone. So here you see it become a ketone. So what will be the product? Actually not a benzyl alcohol, this is normal alcohol. So this will be oxidized by this is oxidized by from what? This will be from ketone and this will be from ketone. So overall what will be the product? Product will be this one, A. First option you just see that in this first option what has happened, the lactone will form to lactol, and lactol in presence of this one you have to do Grignard reagent reaction you have to get, and then PCC you have to get this one. So this is the overall application of this reagent chemistry. In this video you go to you just see what will be the difference about different examples. In this way you have to approach. Main thing is you have to study properly with this reagent chemistry. With a little their basic application they are given to you. So according to basic application you have to approach and you will get. So best of luck all of you.